Today we are moving on to lesson 6.4, which is on polar form and rectangular form. So first thing, when we briefly discussed what polar form is, it was the magnitude, comma, and angle. So we're still looking at that, but we're going to take it one step further. We're going to now graph on a polar coordinate. So this looks like a polar graph here. When I graph it, r is my magnitude and theta is my angle. So again, theta is that rotation, always starting from here, going counterclockwise, and then r is my magnitude. And these are just some additional definitions from your book. So it says r is that directed distance. Again, for our simplified purposes, r is that magnitude. And then theta is that angle. So let's take a look at a couple of points that we're going to graph. So the first one we want to graph is the point 4, 15 degrees. So if we take a look here, each one of these, this would be a 45 degree. That's halfway in the middle, so it looks like each one of these are 15 degrees. So if I wanted to rotate 15 degrees, so I'm going to here, and then if you can see as I'm moving out kind of in that bullseye direction, I'm adding on an additional unit in my magnitude. So here would be 1, 2, 3, and 4. Again, that is point A. Let's go to the next one. I'm going to 60 degrees. So again, each one of these is 15 degrees. So 60 degrees would be here. I would go out 1, 2, and 3, but that negative means we actually have the opposite direction. So we've got a negative magnitude, which ends up pushing it out this direction, 1, 2, and 3. And that is point B. Okay, moving on, 105 degrees. So 90 degrees would be at the top. 15 more would put me at 105, which is here. And again, I need a magnitude of 5. So that would be point C. And I'm just going to switch so these don't go through onto the backside 2 pad. Okay, the next one, pi over 2, and this should be pi over 2 radians, so that would put me 90 degrees, which is here. I have a magnitude of 4, but again, notice it's negative, which puts me in the opposite direction. So that means point D is here. Okay, pi, so we're going over to pi. I've got a magnitude of 6, but again, negative 6 kicks it in the opposite direction, so that would be point E. And finally, the last one, 225, that's a familiar one. That's halfway in the middle of these two, which would be here. And I have a magnitude of 5, and that would be point F. Now, they want us to give 2 more equivalent polar points from point A. So 2 other points like this that gets me at that same location, but they're not 4, 15. So one way I could do this is we could go all the way to here and then go a negative magnitude. So all the way to here would be 15 degrees beyond 180. So that would be 195 degrees, and I would do a negative 4. Another one I could do is I could go around in this opposite direction, so that would be a negative 345 degrees. And again, if I want to stay here, I would have a magnitude of 4. Okay, let's go look at the next one. They want me to go look at point E, which is here, negative 6, pi. Again, this is where I need to end up, so I could also go and do 6, 0 degrees. I could also do 6, 360 degrees. I could also do a 2 pi in here as well. Okay, now what we want to do is we're going to convert from polar form, which is what we have here, to rectangular form. And really, we have been doing this when we look at even vectors. If you remember, when we were given it in polar form, to get it to vector form, we did the magnitude cosine of theta, the magnitude sine of theta. So we actually can do the exact same thing here. We've got And let's just go ahead and visualize for just a moment. 5, 6. So 1, 2, 3, 4, 5, 6. My magnitude is 3. I'm looking for the x and I'm looking for the y. So if you think about that for the moment, to find my x, we could go and do cosine of 5 pi over 6 is equal to x over 3. Notice what you get. X equals the magnitude times the cosine of 5 pi over 6. And in turn, we could do the same thing for y. We could go and do magnitude times the sine of 5 pi over 6. So 5 pi over 6, back to my unit circle. This would be negative radical 3 over 2 times 3 would be negative 3 radical 3 over 2. This distance would be positive 1/2 times 3 gives me 3/2. Negative 200 degrees, let's think about where that would be. Negative 180 would be here. I go 20 more degrees beyond. Now 200 degrees is not a common one on my unit circle, so I would have to go and use my calculator. Again, we're doing 2 cosine of negative 200. Now, if you wanted to type in cosine of 160, it's still going to give you the same value, and then our y-coordinate would be 2 sine of negative 200. So let me grab my calculator. Okay, typing in, I got the values negative 1.88 and 0.68, and just a quick check. Notice I would expect my x to be negative because I'm going left and it is. My y is positive because I'm going up and it is. So to convert from polar form to coordinate form, as we said, all we need to do is go and take r cosine of theta and y sine of theta. And again, just a reminder, r is equal to your magnitude. Okay, now we're going to go backwards. We're going to go from rectangular form back to polar form. So let's go take a look at a few examples there. 1, 2, 3, 4, 1, 2, 3. So first thing I need to do is go and find the magnitude. The magnitude is the length of that vector, which is, using Pythagorean's theorem, negative 4 squared plus 3 squared, and taking the square root, ultimately we get 5. And then the second thing we need is this angle in here, which is theta. Again, we did this when we're vectors. Opposite over adjacent would be tangent, so we have got inverse tan of 3 over 4. Grab my calculator. Inverse tan of 3/4 gives me 36.9 degrees, and I'm going to have to just tweak it a little bit. Remember, if I'm in polar, I'm starting here on the unit circle and I'm going this direction. So to go all the way to here, it would be 180, but then I have to subtract that amount. So we end up with 180 minus 36.9 degrees. And I've got 143.1. So in polar form, this would be 5, 143.1 degrees. Now, just some options here. People might say, could I use that negative when I deal with that 4? I could. So think about that. Inverse tan of 3 divided by negative 4 ends up giving me a negative 36 degree angle, which would be here. So two things. I either have to tweak it and add 180, or think about this kind of based on what we did on the top. We could do negative 5, negative 36.9 degrees. So negative 36 would put me here, magnitude of 5, but then a negative flips me to that opposite quadrant. Okay, let's have you go take a look at letter B. Okay, so typing those in using Pythagorean's theorem, I got the following magnitude, I got the following angle, so I can actually leave it in that exact format. My magnitude is 5.83, my angle is 59.0. So general notes converting from polar form to, from coordinate form to polar form, you've got your magnitude is using Pythagorean's theorem, which is x squared plus y squared. And we know theta is equal to inverse tan of y divided by x. And again, if you look at the back of your formula sheet, these formulas are on there for you as well. Let me show them to you. They are right here. There's that magnitude and there's that angle, the same ones that we were using when we did vectors. Okay, the last piece is now, so we've been flipping back and forth between points that are polar, points that are coordinate. We can actually do the same thing with equations. So a few examples to look at here, and here's a few substitution. Again, all of these are on the back of that on that formula sheet as well. So if I've been given the following equation, rectangular, I know that is equal to x equals 2. When I go put it in polar, take a look at what you have. X is in polar is equal to r cosine of theta, so I'm simply going to substitute. I get r cosine of theta is equal to 2. Okay, a couple ways I want to show you I could check it. I went ahead to Desmos, I graphed r cosine theta equals 2. I can see I get that vertical line of x, or yes, x is equal to 2. Now, if I wanted to check it on my calculator, we could also do that as well. I went into mode, I changed it to polar form, so next to the parametric. I went back to y equals. Now the only thing here is I have to be able to solve for r. So in this case, r would equal 2 cosine of theta. I'm going to go ahead and hit zoom 6. I'm just confirming again that I get the exact same graph of x is equal to 2. Okay, let's go on to the next one. Y is equal to -1. So we know that is here, and we know it is a horizontal line at -1. So again, if I wanted to go change it to polar form using the substitution at the top, y is equal to r sine theta. So this in polar form would be r sine theta is equal to -1. If I wanted to check it on my graphing calculator, I would do -1 divided by the sine of theta. I'm going to grab my calculator. So we've got -1 divided by sine of theta. And again, I'm ending up with a horizontal line through y equals -1. Okay, the second equation that we're going to look at is the equation of a circle. So first thing I'm going to do is go ahead and type in what that equation is. Let's go look at what the graph is. So I've got 4 cosine theta. When I hit graph, I can see I have the equation of a circle. All right, I graphed the equation on Desmos. You can graph it on your graphing calculator. I end up with the following. Now I need to change this so it's in polar form. So let me go back to my screen, and I gave you a hint here. I want to multiply both sides by r. So when I do that, I have r squared equals 4r cosine of theta. Now, why am I doing that? Because up at the top, I can now substitute r squared with x squared plus y squared. I can now substitute r cosine with an x. This is the equation of a circle, which we've seen a little bit here and there. Let me go change it so you can see that. I've got x squared minus 4x plus y squared equals 0. I'm going to go ahead and complete the square so that I can see that equation of the circle. Remember to do that, we're taking half of 4 and we're squaring it, which means I need to add 4 to the left and 4 to the right. So we've got x minus 2 times x minus 2 plus y squared equals 4. X minus 2 squared plus y squared equals 4. Now you can see the center of your circle is at 2, 0, which is what we got. And remember, this value is your radius squared. So your radius would be 2 units, and we went 2 units all the way around.